Guys, in this video we are going to go over some of the basic programming steps involved in staging up a chill water system based upon load demand. If you have a system where you have multiple chillers, this can be very useful and save you a lot of time instead of having to manually go and turn on a secondary chiller, or stage it up or stage it down based upon the load manually. It's a good idea whenever possible to write this type of programming in the main controller itself. However, for this particular application, we are going to be writing it in LCT. This particular system has a total of 2 chillers, and we are going to be adding a lead lag as well as the logic to stage up the chiller based upon its load demand, as well as the logic to stage that chiller back down once that higher load demand is met. And once we don't need it anymore, once it cools back down outside, if you have a real humid hot day outside, you may need that second chiller, but as the day passes, the load will go down, so you need to drop that back out. We're also going to be looking at adding the logic that will bring up a second chiller in the event of one of those chillers failing. If overnight, for whatever reason, if you have one chiller go down, this logic will actually bring up that other chiller in that event. And that way you can keep your building at least somewhat cool automatically, all done within the programming. Guys, you can see in this view here the chilled water system that we're going to be working with. There are a total of 2 chillers in this system, 2 primary pumps, 2 condenser water pumps, and using the load demand to stage a chill water system is a very effective way to automate part of your system. One of the first things that we will need to do is to create a couple of logic blocks, and what we're going to create here is a control system, if you are familiar with LCT, and we're just going to call this chiller staging, and that is where we are going to create a lot of the logic that we're going to be working with. And this, fortunately for us, the chillers do offer the availability of the load to be able to be pulled in to the network, and that is a very key component for this process. We're also going to set these up to run lead lag, so I'm also going to insert a binary value in here as well, and of course chiller lead lag, something generic, something that you can understand. That way we can set up some equalized runtime using schedules and that sort of thing. And we're going to change our state text to lead lag, and we're also going to add a description to this which will identify which chiller is the chiller that will run, depending on what it is. Lead is chiller 1, lag chiller 2, just a little descriptor to kind of make it a little easier for someone who may not be familiar with your system if they come in to do anything. And once we have that done, we are going to start in LCT. Here we are in LCT with a blank slate, and this is where we will build the logic for the chiller staging. And I'm going to show you a couple of the points real quick inside here. This is one of the chillers, and you can see that this particular chiller is directly on our network. This simplifies a lot of the process, and when we pull it over here, you can see here that we have the chiller load. It's the very top point. Now we're going to go down to the other chiller, and you can see it as well. These chiller loads are going to be key to this program. So inside LCT, what I'm going to do is actually pull those points in as part of the calculation. To stage these chillers based upon load demand, we have to pull that demand into our logic. So I highlight the load, and then of course using an input attribute For each of these, I simply highlight the point and then grab an input attribute and I pull that over. And here are my two chiller load demands. Now then, we are going to do a little bit of selection. What I want to know, depending on whichever chiller is running, I want to know what the maximum load demand is. Using this will simply tell me which chiller is running at, the max. It doesn't matter which one's running, but this will break that out as part of this logic. And once we do that, we're actually going to add a comparator block. And of course, if we're going to add a comparator block, we have to have something to compare it to. So we are going to need to go back to our folder where we are building a lot of our logic. And what we're going to do is actually add a comparator block. I'm going to highlight my folder. I am going to go up to my Insert tab. I'm going to insert another object, and I'm going to get an analog value. And this is going to be the value we use to stage up a second chiller. I'm going to give it just a generic name, something that I can identify. This is only going to be one of the analog values that we will be creating. We're going to actually have to create another one that we will do later that will be the stage down value. I'm going to do a little housekeeping here. I'm going to change this to %, and I kind of like using the relinquish defaults, so I'm going to put a value in there as well. These values do get changed once we get the system up and running. These are just to get us started. And like I say, it will change once the system is running and is actually doing everything live, including all of its calculations. Now then, I'm going to pull that value into my LCT screen. This is what we will be comparing it to. There's also, I'm going to have to add another value here in a moment, and it's going to be a differential. But first we're going to go ahead and grab our comparator block and we're going to drag it out onto our screen. We're going to make our connections between the maximum demand and then our set point as far as what it will be used when it stages up. Okay, I'm going to go back here and I'm going to insert another value. This is going to be a differential that I'm going to use for this comparator block. That way it is, it does give us a little bit of flexibility. The values, once again, that I put in here will be all generic. It will be just the what I think is, is going to get it up and running. And these values do change once this system is live. So I'm going to go through here and just throw a relinquish default value in there, just something generic as well. And here we go. Now I am going to also create a differential, and here is my differential value that we've pulled into the screen. I'm going to make the connection there. That way it is adjustable. You can do this as a floating constant. There's several ways you can do it. I just done this one just where I can change it quickly and easily. And now then I am going to pull in an OR gate. We're actually going to need a few of these for what we're going to be doing. Once again, we are going to have lead lag on this. I'm going to change the number of inputs to 3. Of course, we're going to need each of that for the way this system is working. Again, we're going to be doing a lot of things with this lead lag. We're going to have a to equalize the runtime, but we still want our system to calculate no matter which chiller is running. If 1 is running and we need a second chiller, we want it to be able to bring up 2. If 2 is running, we need a second chiller, we want it to bring up 1, that kind of thing. So I'm going to pull in my lead lag point and into the system as well here in a moment. This is the main chill water system enable. I like to make sure that none of the logic can enable unless the system enable itself is on. So I like to link that in the logic in a key point to where it will keep everything else down. You do not want this system to start if that main system enable is not turned on. That should be the master switch in anything that you're doing, any kind of programming that you're doing. Fortunately for us, these chillers also have an alarm output that is tied to the DX. I'm going to pull both of those in here as well, because what I'm going to do is actually use them to where if one chiller trips, it will automatically stage up a second chiller. Now, in a building like this, in one of your critical areas, I highly recommend you do this. That way, if you have one machine go down when no one is around, you can actually allow the logic to bring up a second machine and keep the building cool. This does work if you keep your equipment functioning the way that it should, and especially if you have your points, your inputs to your controller, it makes it kind of simply to come in and grab those points, pull it into your logic, and set it up to where it will stage on that extra chiller if one chiller drops out for any reason. You know, you could have a power blink, something could fail, you could, a pump could blink off momentarily for whatever reason, and it, of course, tripped the chiller. And having these alarm points is a great way to automate bringing on the other machine if something happens. It's a very, very, very good time saver. It's something that can really help keep your stress down in many ways. That way you don't have people calling you in the middle of the night or whenever because they've have no air conditioning in a building. So now we are going to pull in the chiller lead lag point that we created earlier, because it's part of our logic as well, and we're going to connect it to each of these OR gates also. Now this is only part of the logic. There's going to be some logic created inside this system that will not be necessary for every system out there. There is some specific system-specific logic inside this. Now you can see here that I have added a NOT gate to one side of the lead lag, because what I put into one of these blocks, I do not want it going into the other. I want it to be just the opposite. That's how the lead lag is going to work. If we do not have the we don't want to trigger both chillers at the same time unless the system needs it. And if you put the same input to both of those, it's just going to turn both chillers on no matter where you got it lead or lag. So you actually need to go opposite on that. So coming out of this, I am making a connection to the AND gate. This is coming from the main system switch. Once again, I don't want anything to happen unless that main system switch is turned on. On the other side of it, I am going to be coming out of the OR gate to those. There's one of these gates, these AND gates, for each of the chillers. Once again, this logic, what you're seeing at this moment, will be changed again a little further along in the video. This is just to give you a little bit of step-by-step guidance on how some of this works. Now, once again, when the demand for one of the chillers is above our set point, that logic block will, of course, the comparator block will show true, and it will stage on the second chiller. Now then, I'm going to pull over as an output reference. I'm pulling over each of the chiller system commands, and I'm making my connections here. Simple, straightforward. I like to use a priority 12 on anything that I do on LCT. Using a consistent priority value depending on the type of logic you're doing kind of helps simplify some of the troubleshooting when you have to go back into your system. So that's something that I like to do as well, and it will make it a little easier in the future. Now we have got a good start on the logic to stage up. We will be coming back adding some timers and a few other things. Here you can see the timers that I've added. One of the reasons that I've added these timers is I don't want it just flipping these things on and off. I want there to be a minimum amount of time that it runs. I want there to be a minimum amount of time that it does some comparison before it actually stages up. You can see the addition of the timers here, and that way we're not slamming chillers on and off continuously. You don't want to, start a machine and then 5 minutes later shut it down. That's very hard on a chiller when you do that. It is, it can damage the equipment, so you do not want it cycling the chillers on and off continually. Here is another view of some of the logic that we've had to do. There again, a lot of this stuff that you see here is specific to our particular system. It will be unnecessary for yours. It may not work for yours depending on how your system is configured. To add in a few other things, what I need to do is make a little more room here. What we are actually going to need to do now is we are going to start creating the logic to actually stage down the system. Once the load demand gets so low, we do not want to keep that second chiller running. Any of you all who are familiar with chillers that have worked with them will know that when you run a large chiller with very little load, you will actually start surging that chiller. And if you get a hard enough surge, you can actually trip that machine offline. So what we're going to do is using a selector block to help out for switching between when we are running both chillers and when we only need one. I'm going to make my connection. This whole section that you've seen me move is the comparator for staging up. I'm going to again connect the output of that selector block to my timers, and we're going to begin working on the logic to stage down. We have got to create a stage down value, in which will be once the chiller runs for a specific period of time at a load below this value, then it will switch over and drop one chiller out. You can see here I am pulling over the value that we created, the stage down value, using the same thing, using an input reference. I highlight it and drag it into my work screen. And you can see we have quite a bit of logic here, but once again, most of this is specific for our system. So I'm going to move this up to give me a little more room. We are going to be pulling in a couple more comparator blocks. And let's see here. Yeah, we're going to grab this comparator block. And what we're going to do here, once we get our comparator block onto the screen, is we're going to connect our stage down value. Once again, when the total load is below this value for a long enough period of time, it will drop out that second chiller. I'm going to come out of my maximum output. Again, this is the comparator between the two chillers. This is the selector of showing which chiller is pushing its maximum load. And I'm going to connect this to the other side of my comparator. I'm also going to create just a floating value here, just a differential, nothing specific. I'm actually going to have to create a couple of them that you'll see in just a moment. I'm going to make that connection here. That is my differential. Coming out of here, I am now going to connect this to the other side of our selector switch. And whenever the selector switch is in one position, it will look at the stage up values. Whenever it is in the other position, it will look at the stage down values. Now then, that leaves the question, what are we going to use to control the switch? The answer to that is simple, a lot more program logic. And what we're going to do is actually look at both of the outputs for the chillers. We're going to look at the load for both of them, and we will actually use that to control that switch. Okay, let's get us a little more room to where we are going to add our logic. I'm going to need a couple more comparator blocks for what we're doing. I'm going to pull over a couple of these. Now, I did have to switch the comparator as far as the greater, less than. There's several ways you can do that, but I did have to switch that on these, which is no big deal. But, once you get them into the screen, you can simply double-click and change it. but it's very simple to do. So now I'm going to pull over a second comparator block. Now I also am going to need an additional floating value. Let's pull these back here to give us a little more room to work with. Sometimes we can get quite complex in the way that these work. I have connected this one floating value. You can see I have it connected to the differentials on all three of these comparator blocks, which works fine, no issues whatsoever, does exactly what I need it to do. But I also want to connect an additional floating value because I want to put in a hard value of demand, basically. That what I want is when I'm going to put a 20% in here, and these blocks are going to be comparing the chiller load to this hard value, and we're going to run both of those through an AND gate here in a moment. I'm going to connect this 20% that I have here. It's going to be connected to both of these comparator blocks. I simply click here, I make my connection here, I click again, and I make my connection up here. And then I'm going to go and connect my output. Once again, this is my load from the chiller, each of the chillers individually. This is my demand. I'm going to connect those to those comparator blocks. Once the command or the load for both of those is greater than that 20%, what that is going to do is flip the AND block value. Once I make my connections here, and the output of this AND is going to go to our selector switch. Now we do add a timer to this to give it a little more functionality. I don't want it to get too quick, so I'm going to grab a timer and drag on here as well. Then I double click into it. I put a little bit of time in that, just kind of a little bit of a switch debounce, but basically is all it is. And I'm going to select on delay. Press OK, make my first connection to my timer. Then the output of this timer will go to the switch itself. That when we see that there is current on both chillers, when there's load on both chillers, that is when this switch will switch over from looking at the stage up value to looking at the stage down value. That is a key component in this overall scheme. I do have to swap this once we get it up and running. I did notice that I had that opposite of what I needed it to be, so I did swap it, which is quite easy to do. You can either move the connections on the selector itself, or just to keep the screen looking a little bit neater, what I actually did was simply grab a NOT block. I just inverted it, which is just a little bit of it's a Boolean block. Drag it out there, no big deal whatsoever, and all it does is just simply invert the output from that timer, and that way it gives it it keeps it a little bit neater on the screen. It does get quite filled up, but once again, what this will do is when it sees current from both chillers, which you can see here we're starting to run. We have current on one of the chillers, and we are above our value here, so it is going to stage up. Here is our value, this is our differential, and you can see here that it is true. I'm putting that output out, and the timer is currently timing. There's two timers in series. One is a time on and the other is a time off. That way we're not smacking chillers on and off every 5 minutes. It has to run for at least a half hour. And once the first timer will time out, it will go through the remaining logic and it will fire the second chiller. And once we bring up that second chiller, you can see here we have our command for the second system is currently off. The main system enable is on, but the command for that second chiller is currently off. But once that timer times out, it will go through the remaining part of the logic and bring on that second chiller. And we will give it just a moment so we can see some of that happening. Here we go. You can see the output of the timer is true, that it has timed out. It is now on, and in a moment you will see current or a load on the second chiller. You can see there's our second system. It is now staged on. Here in just a moment you will be able to see a load on this second input, and then the switch will flip. And you can see here we're waiting that it has flipped, and now the system is running with both chiller outputs, and it will remain running with both chiller outputs on until the total demand falls below, or the maximum demand falls below this value here, our stage down value. Once again, you will have to play around with these numbers to get it close to your system. Now, generally, 50 and 100 will be a good baseline value. Once you reach 100% load on one chiller and it remains there long enough, that's when you're going to need that second chiller. Once your maximum load drops to 50% or below, that's when you need to drop out that second chiller. So I'm going to override this value here, and notice what it does to my stage down comparator. It actually flipped that to false. What that will do once that goes false is it will send that false value through the selector. It will then go to the time off timer, and once that has timed out, it will drop out that second chiller. Once the second chiller drops out, we will see that we lose current on, or we lose our load demand on one of the comparators, and we will then actually switch back to the stage up value. That is the key to the way this system works. Once you have it up and running in using both chillers, if you do need to stage it down, you will stage down and switch back. Once again, guys, a lot of the program blocks that you see within this particular system is specific to our needs. Your needs will probably be a little different, but following the basic programming steps, you should be able to get this up and running with a few issues. Once again, we are doing a comparison between the stage up value. Once the chiller load demand remains high enough for a long enough period of time, it will stage up and bring on that second chiller. Once that second chiller actually comes online and it is proven that it is under load, the comparison blocks there will actually switch the selector switch. And once the selector switch is turned to the other blocks, it will then look at the stage down value. Once load falls back down below the stage down value for long enough, it will then drop out that second chiller. Once that second chiller drops out, we will then lose load on one of those chillers, which will then shut down and flip that switch back to its original position. Anyways, guys, I hope this video was helpful to you. This is a lot of complicated programming, but it is something that can be done, and it is something that is very effective. Hope you liked the video. Be sure to give it a thumbs up. Also, be sure to subscribe and drop me any comments and questions down below. Thanks for watching.
Yeah.